Okay, our discrete distribution, probability distribution ROP problem. So we have a company that sells 1,350 on an annual basis. So we are given annual demand is 1,350. Okay, and our order quantity is given as 300. Okay, right there. Holding cost, okay, holding cost is given below. So the carrying cost remember is holding cost, is $5 per unit per year. So this will be on an annual basis, and the stock out cost is estimated to be $6. So we'll use the notation C sub S. Okay, C sub S stands for cost of stock out per unit. So that is $6 per unit. Okay, and we will use the notation SS for safety stock. And we are given in the problem that assume that the ROP with no safety stock equals 75. So this is our ROP with safety stock is equal to 0. Okay. So now we have to calculate the annual cost for each of the different ROP candidates. So what if we set the ROP to 80? What if we set the ROP to 85 instead of that 75? First, let's look at how to compute the cost. So we have total annual cost for ROP. So this is equal to annual holding cost plus annual stock out cost. So that is equal to, this is for the annual holding cost is for the stock, for safety stock. So that will be the safety stock times H plus, now we need to compute the expected stock out, okay, per order cycle. Times C sub S, the cost of stock out per unit. So this is your stock out cost for one order cycle. Now we have to multiply that with N, where N is number of order cycles per year. And that is equal to D over Q. And for our problem, this is 1350. Okay, so D is 1350 divided by 300 is 4.5. Okay, don't round this because this is on the average. We have 4.5 order cycles per year. So now we're going to calculate this cost for each of the three cases. So let's start with Q equal to ROP equal to 75. So we'll start with ROP of 75. Now ROP of 75, the safety stock is 0. Okay. So our annual holding cost for safety stock, so that's also 0. Okay. Now, annual stock out cost so we have to compute the expected stock out. So we have to first compute the expected stock out, and then we have to multiply by C sub S, which is 6, and then N, which is 4.5. So, okay, so our ROP is 75. So if the demand is 60 or 70 or 75, there will not be any stock out. So we don't have to worry about these three cases of demand. We have to only worry about 80 and 85. If the demand is 80, then we will have, okay, we had only 75, now the demand is 80, so you will end up with 5 units of stock out, and that probability is 0.15. Plus, a stock out will occur when the demand happens to be 85, in which case the ROP is 75, so your stock out will be that times the probability is 0.15. Okay. Times $6 times 4.5 order cycles. So that is equal to 60.75. So total annual cost will be 0 plus 60.75 is 60.75. Okay, now let's look at the second case. Okay, now we set the ROP to be 80. Then safety stock will be 80 minus 75 is 5. Okay, we have added 5 units as safety stock. That's why your ROP now is 80. So our annual holding cost for safety stock is 5 times $5 per unit. So that gives us $25. Now the the stock out cost, okay, so now we set the ROP to be 80. So if the demand is 60, 70, 75 or 80, there will not be any stock out at all. Stock out will occur only if the demand is 85. In which case 85 is the demand, ROP is 80, so 85 minus 80, and that probability is 0.15. So 0.15. Now that is the expected stock out times $6 times 4.5 order cycles will give you 20.25. So our total demand, your total annual cost is 25 plus 20.25 equal to 45.25. So that is the second case. Now let's look at the last case, which is 85. So if we set ROP to 85, then 85 minus 75 will be the safety stock. Then 10 units times $5 per unit will be your annual holding cost for stock, for safety stock. Now there won't be any stock out at all because we have set the ROP now at 85, so the demand can never exceed 85, so stock out cost is 0, so your total cost is 50 plus 0 is $50. So now comparing these three, this one is the minimum cost. So the least total annual cost is $45.25 for ROP equal to 80 with safety stock equal to 5. So this is how you'll compute your ROP if the demand during lead time follows a discrete distribution, like specific values. So demand during lead time can never be anything else other than these given values. Then you follow this procedure.